Hi, everyone else. What are you doing?
Watching lectures and doing notes.
Cool. Okay. You do you.
Yeah, I just been listening.
Okay.
um, Dr. Ismer, I kind of wanted to go back just to 11.2.
Okay.
And so with that geometric theorem that you said that if that x ratio is less than 1, you said that it's equal to like a over 1 over x.
Mm-hmm.
And then in your lecture note, you kind of went through the derivation of why it's equal to that, and you came across the limit. And so I was like wondering, because like there's a greater than or equal to it, that limit as n goes to infinity of a times the quantity of 1 minus x, and yeah, that.
Mm-hmm.
And you said it diverges if 1 um, is equal to x, and I'm just trying to like, how would you compute that limit?
If 1 is equal to x.
Yeah.
Yeah, because I just said, okay, I see what you're saying. I was like, okay, it diverges, and we could see it, right? It diverges if the magnitude of x is strictly greater than 1. Do we feel
Yeah.
like we got that? And we can see it converges if the magnitude of x is strictly less than 1. But why does it diverge when x equals 1?
Yeah.
Okay, I see. So that's, and I did just say that, I didn't explain it. So let's think about it. So here's what I think happens. I think that when x equals 1, remember that in a limit we can cancel things?
Mm-hmm.
Okay, so we would have a times 1 minus x to the n all over 1 minus x, but I claim that, God, how does that factor? I'm not sure about this, but I'm pretty sure that 1 minus x to the n factors as minus x to the n minus 1, minus x to the n minus 2, minus x to the n minus 3, etc. to 1, and it canceled with the x minus 1 in the denominator. Let me move that a to the front so you can see what I mean. So I would have an a out front. Man, hold on. I've got an a, I've got my limit, and I'm trying to factor 1 minus x to the n to have a 1 minus x factor.
Okay.
Okay, so in this computation, if x were 1, we technically shouldn't be able to cancel, but we're in a limit. So I'm going to cancel them.
Okay.
Okay, now what's the limit as n goes to infinity if x equals 1? Wait, this is wrong. This is not the right way to do this. Boop. Boop. All right, starting over. Let's try this again. Let's go back to the form of our geometric series.
Okay.
This will do it. So if x is 1, what does this look like?
It would just be a times 1.
Yeah. So you'd be adding up whatever a is infinitely many times.
Okay.
And that, unless a is 0, its limit as n goes to infinity of its terms is not 0, right? So this would diverge. So you're totally right. This partial sum is not what tells you divergence at x equals 1. It's actually the original series form.
Okay. You have to go back to the series. Yeah, and the way I was trying to interpret it myself was like in the beginning of the video you were talking about how like series are kind of like integrals, and
Yeah.
if that x is just a constant, then it just would be like a horizontal line.
Yep.
And it'll go on infinitely, and the area under it is just continues on infinitely and never converges.
Good. You've got all these like rectangles smashed together, but they're all the same height.
Yeah.
I like that. My-
And
Go ahead, sorry.